All right, hello, welcome to this presentation. This is on Decentralized Cloud, and it's on how the intersection of blockchain, decentralization, and open source is impacting cloud storage. A little bit about me. I've spent most of my life trying to convince people that weird things around open source and decentralization are good ideas. So I began my career running the payments and SSL divisions of VeriSign back when it was a weird idea to do secure transactions across this thing called the internet. Served as CEO of Gluster, which some of you may be familiar with, but back then it was a weird idea that you'd take a open source software-based approach towards doing file storage and do that across commodity hardware. Spent about 4 years as CEO of Docker, trying to convince people that this weird open sourced approach towards these things called containers would be a better way of building and shipping and deploying code than using VMs. And now I'm on to my next adventure, which is storage, which is Decentralized Cloud. And I'll explain what I mean by that in a little bit. But first, I'm going to try a little experiment and try to explain it to you the way I will explain it to my relatives when I go home for Thanksgiving, which has never been a successful part of my career. But the way I intend to explain this is to sort of say that we're like Airbnb, except instead of people renting out spare rooms in their house and other people staying there, we're going to be enabling people to rent out spare space on their hard drives that can then be used for cloud storage. And in fact, we are now operating 150 petabyte cloud storage offering, but we own no disk drives. All the disk drives that are part of our network are run by individuals or data centers who have spare space on their hard drives. And that may seem like an odd, bizarre idea. How could you do that? How could you do that securely? How could you make something that would be enterprise grade? And yeah, I agree, this is a weird idea. And what might make it even weirder is that people are trying to do the same thing for compute and for networking. But so to try and convince you that this is not that bizarre of an idea, and by the way, as soon as I explain this way to my relatives, they'll almost certainly turn to me and say, oh, so you're in computers, can you help me fix my printer? And then complain about AOL or something. But I'd like you to imagine a long time ago, a deep, dark age for our world, actually, the Earth about 1993, and imagine what telecommunications used to be like. And I think there are some people in the room who are old enough to remember when telecommunications was basically AT&T, whose logo kind of looks like the Death Star. But back then, telecommunications was highly centralized. Although communication volume was increasing rapidly, prices weren't really falling. It was still about 10 cents a minute to make a call. There wasn't a whole lot of increase in capacity. But the argument was that the only way you're going to get communications that are secure and reliable and compliant will be if they're built by individuals, built by companies who invest billions of dollars in building up secure infrastructure. And sure enough, these companies did a good job of building up infrastructure that was pretty reliable. They raked in tens of billions in profits. But that was the way that telecommunications was done. And as far as open source, well, that was, I think that was described as a cancer by the then chairman of Microsoft. And of course, let me just do a little experiment here. How many people here have sent some kind of a message across the internet today? This is kind of like, do you have a pulse? Okay, how many of you have done it in the last 3 minutes because I either said something interesting or something boring you don't have to reveal? Probably the same sort of thing, right? All right, so how many of you, in the course of sending that message, were really, really worried about which routers or bridges that message was going across? Or really concerned that some of those routers might go down, or that worried about who was running those routers, or what version or model of router that was, or you cared that the message you're sending now is going to go across a different set of routers than the one that you sent 2 minutes ago? And the answer is probably none, right? If you did care about one of those things, raise your hand. All right. Thank you, sir. Did you do anything about it, though? No. Okay, there we go. All right. And let me ask another sort of question that is probably a do you have a pulse question. Raise your hand if you wish we could go back to the time when all communications were run by AT&T. Obviously not, right? I mean, not only did it turn out that a decentralized internet was a better way of doing telecommunications, and it was better for reliability and better for security, but obviously there have been orders of magnitude reductions in prices, and more importantly, the openness has really enabled a whole new ecosystem. So fast forward to today, internet is big and decentralized, and cloud computing, of course, is really popular, but cloud computing is, if anything, far more centralized than even telecommunications ever was. Right? Cloud computing is basically run by 3, or if you count Alibaba, 4 of the largest companies on the planet, and it's very difficult for even the bottom 3 to compete with the top 1. Taking this and not just talking about cloud computing generally, but cloud storage. Storage volume, of course, is increasing rapidly. You all know that. I think the latest statistic is that the world's going to create 44 zettabytes of data this year, which is enough to fill a stack of CD-ROMs up to the orbit of Mars and back. And storage prices have gone down, at least as far as drivers are concerned, but cloud storage pricing hasn't come down by more than 10% in the past 5 years. It seems a lot, right? And again, the argument is, well, the only way that you can do storage or compute reliably, do cloud computing reliably, is to have it be done by trustworthy organizations who spend billions of dollars building up infrastructure. And of course, they're breaking in lots and lots of profit. Actually, the cloud computing market is supposed to be a $180 billion market this year. And as far as open source, well, good news, I guess, is that open source is now widely adopted and sort of now almost the default. In fact, 2/3 of all cloud workloads are open source, and that's not counting Linux. If it's Linux-based, it's closer than 90%. But of course, most of that is being used as a loss leader for the public clouds. So what could we do? How could we approach this? Oh, by the way, another fun fact, apparently 90% or so of all disk drives on the planet are less than 33% utilized. So there's lots and lots of open space. Is there some idea you could do to try and solve this? And of course, my central thesis, the reason why I've sort of come over to storage and why a lot of other people are doing things like storage except doing it for compute, is the notion that, hey, just as open source and decentralization really fundamentally changed the way that we did computing over the past 2 decades, we think that it'll actually change the way that we do cloud computing. And it's my belief that storage will lead the way in much the same way that the first offering from AWS was actually S3. It wasn't EC2, it was S3. So I'm going to talk a little bit about decentralized cloud, the connection between open source and decentralization, try and answer the question that I expect a lot of you are asking, which is, can you make it enterprise grade? Well, I will talk about blockchain. The previous speaker did a great job of introducing blockchain and talking about it in great detail. And so I won't spend a ton of time on blockchain itself, but rather how it and other techniques are used in order to build a decentralized system. And then talk about what this means for open source, what it means for people who are contributing to the network, and probably most importantly, what it means for developers of storage. So quick definition, decentralized cloud, it's a fundamentally different technical and economic model for delivering infrastructure where things are not controlled by any single individual or company. And it's built off of open source and the principles that underlie the internet. So before we get started into this, I do want to clear one thing up. Normally when I say decentralization or blockchain, people immediately say Bitcoin or Dogecoin or something else like that. And from my perspective, cryptocurrencies are interesting, but they're a small part of what blockchain is all about. If you saw the previous speaker on the main stage, you heard about blockchain in supply chains, which is really, really an interesting thing. But even blockchain is a small part of what decentralized systems are really about. Essentially, when you are building a decentralized system, what you're trying to do is build a system that is sort of very different in its approach than a centralized system. So if you sort of compare, Bitcoin or Ethereum to Visa, in one case you have a centralized authority, in another case you don't have a centralized authority. In one case there's potentially a single point of failure. Other cases there's no single point of failure. Centralized systems tend to rely on being opaque in order to be secure. Decentralized systems, almost by definition, have to be open source so people understand what methods are used, what algorithms are used. Security is not just about people who you have to trust, but it's also about math. In the same way that if you want to send a secure message across the internet, you don't try and trust each person who's running a router. Instead, you encrypt it, and then you don't worry about it. And while people often use the term trustless to describe decentralized systems, what it really means is instead of trusting individuals who, even myself, are fallible, but instead you really trust large open communities and open code. So, but in many ways, open systems are similar to open source. So they take a lot of the notions that went into open source and kind of extend them. So of course, any open system like we're building at storage or people are building to replicate EC2 have to be open source because, of course, how are you going to trust the system if you don't know the code it's based off of? Decision making is also kind of extended in the same way that open source does. So instead of, it's not just transparent and open, but in fact algorithmic. So who gets to join the network, who doesn't get to join the network, where data goes, how it gets moved, how people get paid, how much they get paid, is all done by algorithm, which again reduces the need for people to trust that an individual will do the right thing. Security model, just as an open source, we sort of like to say instead of having secret methods that nobody knows. We assume that if we make the algorithms known and have lots of eyes on it, that it'll actually be more secure. And in decentralized systems, you sort of extend that notion to having many actors and no single point of failure. And as far as community goes, well, essentially there's no such thing as a decentralized system without a large community. So a lot of good examples of this, of decentralized systems. I'm going to go into a little bit of detail about the one that we're running at Storage, which is storage-based, and trying to answer this question that I suspect a lot of people have, which is, can you actually make this enterprise grade? Storage was started in a dorm room in Morehouse College by Sean Wilkinson, our founder, in 2017. And he sort of had this notion that if Airbnb can be the largest hotel chain without owning a single hotel room, if Uber can be the largest taxi company without owning a single taxi, could you build the largest and ultimately the most secure, resilient, performant, and economical cloud storage service without owning or operating a single data center? So he set up a bold idea, which is what you get to do when you're a junior in college. But it was actually a pretty simple notion, right? It was set up saying, OK, we're going to, for every dollar we receive from people who store data, we will pay 60 cents back in the form of cryptocurrency to the network, and let's see what happens. And a year later, this is what the network looked like. So 150,000 node operators in 180 countries, representing a total capacity of 150 petabytes, which, as you know, that is a pretty large data center. It's a large global data center that didn't take billions of dollars of capital to build. Instead, we built it, of course, just by compensating people as they contributed capacity to the network. And I think an interesting point of comparison is if you compare this map, and of course each of these numbers sort of represents the number of node operators and where they're located, compared to the total public cloud market, where there are a lot of data centers, but they tend to be fairly concentrated. And so we managed to build something that was far more global, far less expensive in a short amount of time. Now, full disclosure, what we built was a petabyte scale network that was good for bleeding edge distributed centralized applications. And what we think the world really needs is something that's exabyte scale and that can actually work for standard applications that use object storage. So that means it has to be very secure, it has to be very performant, it has to be very durable. And so we started rebuilding from scratch. We're now in beta with the next version of the network. And I'll talk to you a little bit about how it's built and also share with you some numbers about what we're doing to make it enterprise grade. So our basic model is we want to be highly distributed and ridiculously resilient. We run across that big decentralized network. And our targets are to be easy to use, S3 compatible, 25 to 100% faster than AWS or equivalent, and be more durable at a fraction of the price. So let's see if we can actually deliver that. Talk about how this is set up and how it works. There are three main actors in this system. There are customers who have applications. These can be S3 compatible applications or native applications. There are the people who operate the nodes. We call them storage node operators, or SNOs. And those are the 150,000 or so around the world. And then there's a big network of satellites, which are essentially metadata services that all they know is they know hashes and they know the locations. They don't know anything else about the data. And how do things work? Well, as you might imagine, if you have an application that needs storage, before you upload anything to our network, it gets encrypted locally using keys that only you have. So you don't have to trust anybody, including storage. The data is split up into pieces, and those pieces are distributed across the network. Sort of double-clicking on that, the way we split up the pieces is we use ReedSolomon erasure coding, which is not fancy, sexy new technology. It's technology that's on the Voyager spacecraft as well as others, right? But it's on every DVD. But basically, it allows us to divide that encrypted file into 80 pieces, which is what we normally do. We do 80 pieces, of which any 30 can be used to put it back together. And then each one of those 80 pieces is put onto a different drive in the network. And it's a different drive. Each one of those drives is run by a different person on a different power supply, in a different geography, on a different network, with different software. And then the system as a whole, as you might imagine, gets a little bit complicated, but we use peer-to-peer technology, so the nodes are making sure that other nodes are up, and so we have a constant, of course, measurement of which nodes are up. We also do frequent and random cryptographic checks to make audits to make sure that people are storing what they claim to be storing. And those audits are really easy to pass if you're storing what you say you're storing. They're really hard to pass if you aren't. So what does this end up doing? Why does this end up making a really interesting, not only interesting, but robust and durable and performant system? Well, let's start by talking about durability. So as I mentioned, your file is encrypted. It's split into 80 pieces, of which any 30 can be used to put it back together. And each of those 80 pieces is on a different drive, again, run independently, statistically uncorrelated, powered, networked, located by different people. So what would it take for you to lose a file? Basically, you would have to lose 51 of those drives. 51 of those drives would have to fail independently before we did a repair. And so let's assume that 2% of all drives fail a week, which, by the way, is a really high number. For 51 drives to fail, independent drives to fail in a week would be something approximating 0.02 to the 51st power, which I can't do in my head, but I can assure you is a really, really tiny number. Within an hour, we know, or less, we know when any drive has failed. And so long before any file has dropped below, let's say, 65 pieces available, we do a repair. And so as a result, since we moved into as I mentioned, we're in beta. Since we did our last major cutover 4 months ago, we've had millions of files, and we have not lost a single file. And we can look at every segment of every file and actually that nothing has been lost. What does this mean for security? That's normally a question that people ask, but actually we've heard from people who worry about this sort of thing that actually the approach we're taking is kind of similar to sort of spreading encrypted sand on an encrypted beach. So if I wanted to get Alice's file that was stored here, I'm a nefarious individual. Of course, it's encrypted, so storage doesn't know what it is. Theoretically, Alice is the only person who has the keys. We can't mine the data. If a hacker wanted to get at that file, they'd have to somehow find those 30 drives out of 100,000, 150,000 or so. There's no single misconfigured print server or administrator who's vulnerable to a social attack or to blackmail or a clumsy individual who can somehow compromise. But even if you manage to somehow, for Alice's file, get to 30 different people, all you'd have would be encrypted blobs. And even if you manage to not only get to those 30 different drives, but have her file, you'd only have Alice's file. Bob's file is going to be on a completely different set of drives. And in fact, if Alice's file is larger than 64 megs, the second piece will be on a larger file. So you have to start over again. So in fact, there's no honeypot for storage. And it provides, just as there's no fire or flood or cat kicking over a can of Coca-Cola that can cause you to lose a file, it's also really, really difficult to compromise a file. And as far as performance, well, as you can imagine, if you have lots and lots of drives and the workload is spread, you get the benefit of parallelism, and that's for both upload and download. So let me put some numbers behind this, because this is, these are I know, bold claims. So we are in beta now. Our current stats on durability, again, 100%. Retrievability, so this is the likelihood out of 1,000 attempts to get a file that you will get it on the first time, and it fails roughly 7 times out of 1,000, in which case you have to try again, and then it obviously happens on the second time. Upload time for a 100 megabyte file is 2.15 seconds. Interestingly, for the 95th percentile, so if I uploaded 1,000 files, 100 megabyte files, the fastest 500 would be in 2.15 seconds or less. Interestingly, the next 450 will be only slightly slower than that. And that's, again, not because we're doing anything magic, it's because of the benefit of parallelism. Right? Slow drives don't, individual drives can be slow, can have hot files, it doesn't matter. Download even better. We, of course, set a set of goals for beta 1, which we're in right now. Beta 2, we're planning to enter in 1 to 2 months once we've passed all of the goals, but for the most part, we've already hit our milestones, and then launch, we're aiming to be even better. And just to put some more math behind the durability question, which is what people tend to worry about a lot, this is a graph that shows across the entire population of millions of files, how many of those 80 pieces are still available. And as you can see, the median, which is the purple line, is right around 75. We also, of course, track the worst performing file in our system, which as you can see sort of sits around 60. We kick off repair anytime a file gets to 55. And so as a result, what we have seen is that over the course of time, no file has been lost. And it would be very, very difficult for any file to be lost, just because of the way the system is built. So I think that this approach, which, by the way, we're not the only ones doing this. There are companies like MadeSafe and Saya and Filecoin who are also approaching decentralized storage in the same way. And there are others who are doing the same thing for compute. A lot of interesting things about it. I happen to think the economics are really interesting, too. So as a consumer, you get all the normal benefits of cloud, so scaling, low fixed costs. But there's also great supply-side economics. So it doesn't take us billions of dollars to build out a network. And for the most part, the people who are operating in nodes that they're renting out spare room to us have great economics, too. So it doesn't take any more electricity to run a drive at 25% capacity versus, or 75% capacity versus 25% capacity. And for the most part, this is already equipment that's around. They're using non-peak hours. They're not hiring new people. They're not having to build out new fire suppression systems, et cetera. And so as a result, we're able to give what is a really attractive offer to the people who have spare capacity either at home or in data centers to monetize in a way that's almost all pure margin for them. And the result is we can profitably provide storage at a price that is a fraction of the price of the cloud service providers, and we think that will only go down over time. In much the same way that the decentralized internet drove down telecommunication prices. Also interestingly, it provides a new economic model for open source. So it's something that I kind of care about. As I mentioned, right now, a big challenge for open source is that the biggest monetization model for open source these days isn't open core. It's not service and support. It's not professional services. In fact, it's the use of open source as a loss leader to drive consumption of compute and storage at the large cloud providers. So I believe that we've passed the era where it was kind of dramatic to say that the network is the computer. In fact, we're now at a stage where the network is the marketplace. And the nice thing about marketplaces is that when you set them up, you can create new dynamics. And so I've already spoken about the fact that rather than spending billions of dollars of building out data centers, we compensate people fairly and transparently and algorithmically for making their drives available. We're also doing the same thing on the demand side. So if open source drives 2/3 of all cloud revenue, why not compensate open source companies as they drive storage to us? So we've set up something that fairly transparently and algorithmically compensates open source companies. So if you're using Mongo and you do a snapshot or a backup, and they have a connector that makes it possible for you to do that using us, they get to share. Same thing with Minio, Influx, Confluent, Kafka, Nextcloud, you name it. We think that's fair for open source. And so if you are also an open source fan and you want to support open source companies, we suggest you take a look at this. It's not charity. It's just for us, it's a better way of building demand. What does it mean for a storage node operator? People tend to, for some reason, ask a lot about the people who are renting out their drives. And again, they tend to be sort of evenly split between individuals who have hard drives that are always on or data centers that have spare capacity. Again, we call them SNOs, storage node operators, and most of the SNOs that we have are good. We like to assume that they're good. We provide incentives for them to be good, but if you join our network, as you might imagine, there's a probationary period where all you get is a small amount of test data, and we measure to make sure that you have good uptime. We do random cryptographic audits to make sure that you're storing what you claim to be storing. And then once you pass that, then you start getting data, and you get more data sent to you as you build up your reputation. Again, there are fair, transparent algorithmic payment mechanisms that are based off of how much you're storing and how much bandwidth is being consumed as people serve data off of you. Now, we assume that most SNOs are good. As we all know in this world, there are some bad SNOs out there. Our system, of course, is built to assume that there are bad SNOs out there. We provide lots of disincentives for bad behavior. Obviously, if you don't pass audits or you don't have good uptime, you don't get paid. And we keep a small amount of what you're owed for any month held until you've sort of had another month of good behavior. We kick out bad actors, and we've designed the system to be resilient to incompetent SNOs. So again, drives can fail. We assume failure is part of the system. We assume that there might be people who would want to try and see what's on their drive. Again, between encryption, splitting things up, and being redundant, we assume that We assume that there are bad snows out there, but even if you're a good snow, of course, Jon Snow knows nothing. Everything is encrypted. Again, you get paid fairly and transparently. And this is, again, not just us. This is a mechanism that's being used by other decentralized providers. And if you are really interested in understanding how reputation is established, there's a long and detailed blog post about that. So just as you can't be an Uber driver unless you maintain a good reputation, you can't be a storage node operator unless you maintain a good reputation. But fortunately, in our case, an incompetent or a bad storage node operator doesn't impact users the way, let's say, a bad taxi cab driver would be, or a bad renter would be in Airbnb. In case you were hoping you might be able to do this on your laptop or your phone, unfortunately, no. You have to maintain 99.3% uptime. We assume that that there will be people who have bad uptime, and that's fine. But we want the average uptime performance to be really good. So this has to, there is a minimum requirement, but it's something that's easily met by people who have high quality connections, and of course, very easily met by people who are running data centers. And question people who are data center operators frequently ask, what happens if I only have spare capacity for part of the year? And it's not a problem, as long as you do what we call graceful exit, which is you say, hey, I need to reclaim capacity because it's the holiday season or whatever. As long as you push the pieces up to us, it's not a problem. All right, so for me, I think the most interesting question, though, is what does this mean for developers? What does this kind of approach mean? What I should start with is saying, obviously, this is not appropriate for all kinds of storage. So if you're running a live database, splitting it up into lots of pieces and encrypting it and sending it out is not a good idea. But if you're doing backups of that database or snapshots of that database, this is a great approach. What we tend to be good at is pretty much everything that object storage is good at. So large files, over a megabyte up to terabyte size, where the static data infrequently changed, where there may be lots of reads. If you're serving video or serving photos, this is actually a really interesting way to do it. And where potentially your economics are such that the egress charges of the normal cloud service providers are problematic. We have roughly 13,000 developers either working with us or on our wait list, as well as large numbers of sort of larger companies, including automotive, financial, healthcare, and kind of the use cases cover the gamut from archival, backup, multimedia storage, multimedia streaming, large file transfer, software distribution, emerging CDN use cases, machine learning, et cetera. To do it, it's not that difficult. If you're already using object storage, it's simply a matter of getting an account and getting an API key. We are drop-in S3 compatible. If you want to try us on an existing S3 application, that's great. If you want to take advantage of some advanced features, of course, we have a native library, which makes things faster, and bindings for all of the major languages. Interesting topic that often comes up is, of course, how do you, if you're encrypting and you're distributing this, how do you enable other people to access the data? And so taking a lesson from the blockchain community, there's a new technology called macaroons, which are kind of like a really tasty cookie. In this case, it sort of adopts a lot of the sort of same ideas that you have around root keys and hashes and HMACs. So essentially what you can do is provide fine-grained access to a particular file or particular folders. You can delegate access so that people who are down the chain can add additional permissions, remove additional permissions, et cetera. And it's very similar to a blockchain, so that, again, cryptographically, without having to go back and check with a centralized service, you can provide fine-grained access control. Again, most of what we have been focusing on is the use of decentralized cloud storage for traditional apps. But a really interesting topic that I know a number of other people are covering at this conference is how do you use blockchain for decentralized storage apps themselves. And this is something that you can use this for, but I think is also a really interesting topic. So while we're a good solution for standard apps, also I think a really good way of extending the notion of decentralized blockchain-based approaches towards storage itself. And so some of the use cases that we're seeing are blockchain-based proof of file integrity. So a hash of any file is then stored on a blockchain, so that there's proof of integrity, and it's very difficult for people to change things without being known. use of non-fungible tokens for digital object provenance, sort of the equivalent of provenance in the art world, except this is for digital objects. Chain of custody, supply chain management, a really fun project that we saw is actually being used for cashews in Benin, which is a big market, but as you can imagine, lots of small farmers who can be taken advantage of by the middlemen in the supply chain. This is actually a way of getting around that by using the blockchain to establish what has been sold, how it's been sold, and keeping a distributed ledger about that, and programmatic file transfer. The proof of file integrity is a particularly interesting one, that, at least for me, and the solution that the individual that's doing this, or the company that's doing this, is basically a hash output of a file that's stored on the blockchain. So there's cryptographic proof at a point in time that a file has not been altered since that point in time. And that's a really interesting application, and it's being used not just for files, but actually even being used to provide security in containers. So, the world comes full circle. So before I turn things over to questions, I'd just like to repeat my central thesis that obviously a lot of what I'm talking about may seem strange and out there, but by the same token, the notion of doing global communications over decentralized networks seemed like a really odd idea 20 years ago. But I believe that open source and decentralization will fundamentally change cloud computing in the same way that open source and internet changed computing over the past 2 decades. And if the past is any guide to the future, I think storage is going to be one of the first and most interesting ways in which this is used. So thank you, and let me open it up for questions. We have about 7 minutes.
So your storage nodes are decentralized.
Yeah.
Your metadata servers
are largely decentralized. They're not fully decentralized. That's the path we're going on. So right now the metadata servers are, as you might imagine, composed of lots of different. Every satellite is actually multiple different servers that are stored in different data centers, backups, and operated by different individuals. But it's not as decentralized as the storage nodes themselves. That is something that we're working towards. But I think similar to sort of the world of hybrid cars, you could, you'd either be all electric, affordable, or have long range, but you couldn't do all three at the same time initially. We've sort of chosen to be less decentralized on the satellites than we have on the nodes and affordability.
Is there any thought to doing the association of all the fragments to the object identifier on the blockchain?
Yes, actually. Part of what so right now, at least in our system, blockchain is used primarily for payments. So for compensating people, customers can pay us either in fiat or in a utility token, and then we pay all of the, the 100,000 people in 180 countries using blockchain. But yes, both for sort of file integrity and for other issues related to metadata, we've thought of using the blockchain. The challenge with blockchain, as you may know, is that it tends to work in sort of seconds or minutes, and most things involving storage people want to have happen in milliseconds. And so,
Well, the lookup would be instantaneous.
lookup would be instantaneous.
In the blockchain.
Yes, yeah, absolutely, right. So, yeah, no, that's actually interesting. And by the way, of course, we are not only open source, but all of our design documents are out in the open. We have a nice 80-page white paper, and if you have ideas like this, we'd love to have you contribute them. Other questions? Yes, sir.
So you divide it into 80 pieces regardless of the file size?
So what we do right now is so every file is broken up into segments of 64 megabytes. And then it's actually the segment that's broken up into 80 pieces.
Oh, segment.
The segment is broken up. And actually it gets even more complicated. We do interesting things with striping so that you can, you can actually scrub 4K video using this. And that 30-80 ratio is also a tunable factor. So if you're doing a file that, let's say, is going to be read by lots of people, if it's a video file that's going to be potentially read by thousands of people at the same time, you can change those parameters. Instead of doing 30-80, you could do 30-1000, for example. But 30-80 works well for most use cases. Yes.
How much cost do you bring down?
So right now we are priced anywhere between a third to half of AWS. And again, we give 60% of roughly 60% of what we take in to the storage node operators, who are able to make, depending on the size of their node, anywhere between $5 to $15 a month, which again is largely pure profit. And of course, over time, we expect that storage node prices will come down, our prices will come down, and again, we think it's a good deal for everybody all around. Yes, ma'am.
So the concept is like Airbnb. So as a node operator,
Yeah.
I actually do use that node as well. How do you
Sure.
fence it so that the lease part?
Yes, it doesn't bleed into the,
Yes.
yeah. It's,
Somewhere, whatever. Somehow I get destroyed because
yeah, so you tell us how much space you're willing to make available. And now obviously, unlike Airbnb, where a guest staying in your house impacts you, in this case it's just encrypted blobs that are non-active that are on your drive. You tell us how much space you have available. We give you constant information about how much of that space we've used. And again, if you need to reclaim it, that's not a problem, as long as you do it gracefully. So if you leave and you take your node offline and you don't tell us, then we might have to repair it. But if you just push the data back up to the network, then you're fine.
you sanitize the data.
So you can. I mean, you could. The software gives you the ability, if you want to sort of restrict where the data is stored to a particular, set of blocks.
I mean, in my head, I'm thinking you have a mass murderer in your Airbnb or something, something like that.
Well, in our case, basically, you would have sort of an encrypted piece of the mass murderer's hand, on your drive. So, yeah, no, I understand. I mean, but actually, I mean, as compared to, let's say, Airbnb, where actually you do worry about these things, both as a, an individual staying in somebody's house, it can be a little weird. People staying in your house can be a little weird. Same thing with Uber. Essentially, in this case, it's just encrypted data, right? Non-active. It's not programs, et cetera. Yeah.
You said the keys are with the customers.
Yes.
Then you said you do checks on the content.
Right. Right.
How do you check the content when you get it?
So part of the metadata that's sent is a hash of the, and I'm going to, at a certain point, get past my technical competence, but there's a hash of the data that's stored with the metadata. And then the challenges that are issued are basically, hey, give us a combined hash of the following pieces that we've stored on your drive.
I think it must be a hash of the encrypted data.
Yes, it's a hash of the encrypted data, yes. Yes, so all we want to do is make sure that the encrypted pieces that you store, say you claim you have, and there's a hash of the encrypted data, yeah.
So what about like bandwidth limits?
Sure.
Capacity, could you say, I only want you to use 100 IOPS?
Yeah. So if you are a storage node operator, you can also set a bandwidth limit. And so what we're seeing is there's sort of there's sort of two categories of storage node operators. There are people who are running home drives where their ISP has a bandwidth limit, and that's fine. So we also keep track of that. And we don't push you over your limit. So there's we've determined there are certain ratios of the amount of data that's being stored and the amount of bandwidth that we use. And so for the most part, if you're a home user and you have a limit, you're going to get archival data that's primarily for archival purposes. If you're a data center and you have sort of unlimited upload, then you'll get stuff that's going to be used more for CDNs. And your economics change. But we don't want you to get a $30 charge from Comcast because we've pushed you over your limit. Yeah.
You said you pay in Bitcoin.
We pay in our native token.
Huh?
We have a native token called Storage, which is Ethereum based, and is traded on 11 different networks. So some of the storage node operators hold, some convert it into fiat, some are actually both consumers and providers, and so both of those tend to work. Yes.
So you talked about average performance that you see, average response times, right?
Yeah.
But what kind of tail do you see?
Oh, so again, it's let me go back to this. If it wasn't clear. Sorry. So actually, I've shown you the tail here. So for both upload and download, I have the median as well as the 95th percentile. And it's actually one of the numbers I'm most excited about, which shows that I'm a numbers geek. But if you look at the sort of download time, for example, today it's 1.69 seconds for a 100 megabyte file. That's the median time. The 95th percentile, so the slowest 50 out of 1,000, right? It's only, what is that, 0.13 seconds slower. And again, that's because we have again, we get the benefit of parallelization, right? If you're pulling, you need to pull 30 pieces out of 80 drives. If some of those drives are slow, it doesn't matter. And if you are in Namibia, you're going to be pulling data from drives that are in Niger as opposed to Nebraska, and that's kind of how it works. Yes?
So are you actually trying to pull all 80 pieces every time, or are you assuming some reassembly?
We basically we broadcast to the 80, and the first 30 that respond get to do so and get paid. And actually, we sort of let 35 respond and get paid as well, just so we have a little bit of a buffer.
If everyone's always responding, you're only ever actually using half of your access.
Right. And so again, what will happen often is that people are, they're busy responding to other requests, or their ISP is down, right? And so, it's generally not 80 that are responding at the same time. As you might imagine, we're also working on some predictive models so that, if we see this file suddenly becomes hot, then we can put pieces on more drives and then take them off when they're no longer needed. Yes?
So the client is encrypted on their device that's letting it up?
Yeah, so they encrypt any data gets encrypted and split into ReedSolomon before it goes up.
Okay, so that takes compute power on the client side. That's right?
Yes, it does.
Okay, so wouldn't that make it slower compared to a traditional cloud storage?
So this time here includes typical encryption time. Right. So the encryption ends up being a fairly small, at this point, the amount of power that's needed to encrypt even a large file is actually pretty modest.
Where do you run? Where does storage run? On Amazon?
No. So first of all, if you ask where do we run globally, right? So we have, of course, the nodes are global. The clients can be anywhere. In terms of the satellites, which is sort of the metadata servers, we are in multiple providers in multiple regions. We have some that we do locally, and we also have partners who are running satellites. And so if you are a data center operator who's interested in being a satellite as well, we have a vetting program as well. But yes, we're looking to have the satellites be as sort of decentralized ultimately as the nodes themselves. But again, we want to design a system so that no fire, flood, cat kicking over a can of soda, or an incompetent administrator can take it down. Right now, again, we are less decentralized with the satellites than we are with everything else, but we are, before we go into beta 2, we will be Chaos Monkey compliant, if you will, so that we can lose individual servers, and before we go into production, we'll be Chaos Gorilla compliant, so that we can lose data centers and be fine, at least as far as durability is concerned.
Do all the metadata servers have equal copy of the metadata, or are they partitioned?
They're partitioned, and they do backups both traditionally as well as onto the storage network itself. Yes, I think we have time for 2 more questions. Yes.
Security, can you ensure that only the portion of the file has been read, not other content of the file?
So I want to try to understand. So again, if you as an individual want to control access to the file, I spoke a little bit about macaroons, and that's under your control. It's not under our control, but we give you the ability to have fine-grained access to files and to segments and to folders. But again, nobody can access the data, including us, without some cryptographic key or portion of the cryptographic keying that comes through macaroons. So I'm getting the hook. So let me just end with, again, if you're interested in learning more, if you're interested in playing around with the system, of course, we'd love to have you play around the system. If you want to contribute, we're open source. If you're an open source project and you'd like to get money for sending data our way, we're happy to share that with you. And if you are really interested, we've got a nice, well-written 80-page white paper that describes in much greater detail than I can how this works. So thank you.